T4S Partners is a consulting firm out of Denver, although we work across the United States with a significant focus in application modernization, cloud technologies, as well as IT operational support. OutSystems is our partner, and OutSystems has the leading low-code development platform and application deployment platform. And they'll be my example as to how low-code is changing the way we look at cloud architectures in general. So I think, there's no surprise microservices is, to use a Western idiom, is the best thing since sliced bread. Another way of potentially looking at the way I've heard microservices described in Kubernetes and such, and containers, is similar to the description given to the Boeing 777, which is 3 million parts all flying in close formation. So the notion is, so now that we have all this technology, what does this really mean? So what we're seeing, though, is really a progression, right, where the initial cloud capabilities was around getting independence from hardware, looking at infrastructure as code. With containers and tools and platforms like Kubernetes, we've gained independence from the OS platform. That is, we have basically a very fluid, very flexible application execution environment. But there's a cost associated with that, and the cost is that the deployment is complex, very simple. Unless you're doing a distributed monolith where you don't really take advantage of microservices. But fundamentally, you still have to deal with a lot of the complexity. So really, this is about how do we gain independence from that deployment complexity and allow for focus on the applications rather than on the underlying platforms and infrastructure. So the one kind of myth that I've heard before, I think everyone here probably already understands this, though, is that containers and Kubernetes are not a microservices architecture. They support microservices architecture. That is, they enable the operations or the operational deployment of application components in the form of microservices to work together, to work reliably, to work redundantly. And again, if you avoid the distributed monolith kind of accident that I've seen before, you can gain a lot of advantages around microservices architecture through deploying via containers and via Kubernetes. So in terms of what is microservice architecture, if it's not Kubernetes and it's not containers, what is it? It's really an application architecture. It's how to design your components so that they can exist independently from each other, allow for even looser coupling between them, and better isolation of things like data and support of contract-based interaction. So another way I've heard applications described nowadays with microservices is an application is actually an emerging behavior of a dynamically set of deployed components. So the notion is that when you design your application, you design it around microservices architecture. Now, there are cases where it may not make sense, but there are several drivers around that, and I think some of the previous speakers have touched on them before, which is around speed, flexibility, the reliability aspects in scaling, as well as essentially for very large organizations, managing the way applications get developed. But there's a step that often is kind of implied, but isn't often. How do you get from a microservices designed application to a deployable platform. And the challenge here is that it's complex. It's not just complex in terms of how you figure out where do things live, how your pods are divided, how those application components need, where they live, how they essentially need to run from a redundancy standpoint, from a performance standpoint. But the underlying technology is non-trivial by far. So and some of the tools that are out there are making this easier, but fundamentally, Kubernetes is really a domain in itself that really has to be well understood if you're doing it effectively manually. And I would say that even with the existing Kubernetes services on the clouds, on the various different public clouds, a lot of that complexity still exists. You still have to figure out how to do this level of configuration. So really, the next step in this process is to gain independence from that complexity around container-based deployment and Kubernetes. You need to work with a system, an application platform that can take care of that for you, that essentially is built in a manner where by designing your applications, and this is where low code comes in, the entire application is understood by the underlying platform, and the underlying platform will essentially take care of deploying it into a microservices infrastructure with all the advantages. So let me give you a couple examples here real fast. So this is a very high-level description or visualization of how OutSystems basically allows you to build your applications, whether it's the user interface components or combination of components. There's some architectural approaches around modularization that allow you to essentially build your application in a very microservices fashion. Today, in the version 11, it will take that application, it will generate the code underneath the covers and deploy everything out to that to the cluster application server. In this case, it deploys into IIS servers, which are highly scalable in their own right, but it's really much more of a VM approach. And then the underlying database, it also implements database changes from a scripting perspective, takes care of so much, and has built-in monitoring and essentially scaling capabilities. Well, over the past month, OutSystems has announced their new platform development, which is called Project Neo. And Project Neo is really their next step in taking essentially their application platform and enabling it to deploy in a complete microservices environment, including, well, at least initially on AWS's various different container and Kubernetes platform, but looking beyond that in a very portable manner. So by doing so, they take care of all that work. Basically, the underlying platform manages the conversion of these microservice and the microservice modularity into specific containers and the deployment of the containers. Now, you may say, well, what about scalability? How does it know which ones need to be redundant? What needs to be deployed where in that cluster? And besides having essentially all the metadata about the applications, understanding all the dependencies between the components, between the modules, it will also have all the runtime information that over time it collects and can apply machine learning and other aspects to essentially deploying it in the best fashion for how that application operates while still maintaining the scalability, the flexibility. So really the underlying notion of low code, in this case the example is OutSystems, is driving that aspect of application development where you don't necessarily care about the details of how it gets deployed, as long as it gets deployed correctly and takes advantage of the underlying technologies like Kubernetes and containers. So these are just some screenshots indicating that it has this kind of complete view of these applications, the deployment, the versioning, the differences, the interdependencies, and their usage over time. So really, this is actually the summary, which is, if you're going to do microservices, you have to understand the trade-offs. I don't think anybody's going to argue with that. That is, I forget who said, oh, James Lewis basically said microservices buys you options. And the word buy is quite intentional there. That is, it's going to cost something in the process. You have to design applications around microservices. You have essentially, you have to give up some aspects of, for instance, being able to query across all data sets very rapidly with arbitrary queries, which is the advantage of relational databases. But in the microservices architecture, when data is isolated between across microservices, you don't necessarily have that capability out of the box, so to speak. The other is that with low code, you can focus on the application architecture, and use techniques such as domain-driven design to build applications in a microservices design, regardless of what you're deploying to. So you could take an application design that way and deploy it monolithically, but at the same time, you can deploy it to a very highly scalable platform. I think the key thing for me here is it's not, in my mind, worth investing a lot of time in building Kubernetes expertise. This is where low code, I think, is going to provide basically the capabilities of managing all that for you. And so you can focus, again, on your application, not on the underlying infrastructure. And so my advice is, look at low code. If you're building applications, if you care more about applications than the underlying infrastructure, then look at low code as a means of getting both, as a means of essentially getting the capabilities around low code and the advantages there, and at the same time, getting all the advantages of a microservices-based architecture, as well as the underlying platforms that support that massive scalability and runtime environment. So that's really it. It's not a lot, but I wanted to make that specific point, which is, if you're going to go to microservices, focus on the application and let the platform essentially do the heavy lifting around figuring out how to get it out there.